Hi, welcome to the Backend course. I'm Mohit Chabda, ex-Salesforce, ex-Walmart, and in today's video we will talk about DTOs. DTO stands for Data Transfer Objects, and it is a very fundamental concept of backend which is frequently used and asked in interviews. So in this video we will see the code example and check out the problem statement and then identify the solution for the same. Okay, let's start with the problem statement. While building the backend project, you would have entities, and sometimes you may expose the entity directly to the outside environment, and that is a very bad practice because it exposes a lot of risk. Let me show you that with an example. So here you can see this is a Java code and this is our entity class. This entity class has name user, and you can see some of the fields that are present in user entity. It has the ID, it has the username and then password, and then other few fields like created and updated at. And with this we would also have some getters and setters. Now the actual problem comes when you expose this entity from your controller. Say for example this is your user controller class, right? And inside this you can see what we have done is like exposed the user entity. This is a getter method, get user, and what it is doing is like using the repository. It is basically giving you the user. So in this method you are actually exposing your entity, which is user, directly from your controller to the outside environment, and it can cause a lot of issues. But what issues? Let us see some of the issues which come when you directly expose your entity. The number one issue is that it is a security leak. You are exposing sensitive internal data to the outside environment. For example, in our user entity, there is a sensitive field called as password. And when we expose our user entity, with this, we are exposing our sensitive field like password to the outside environment. So here you can clearly see this can expose a security leak. The next problem is that it creates tight coupling. Now, because you have exposed your entity, here you can see this user has ID, username, password, and some other fields. Say in future you want to change this field name from username to user underscore name. So you simply want to update the field name, but it will cause issues. It will break the API because the front end is using the field username because we have exposed the complete user entity to the front end. Here you can see we have exposed this. Now the front end would be using the same field name, but say for example you update it to user underscore name, it won't work for front end because they would also have to change it. So it creates a tight coupling which we don't actually want. So this is one of the issue of directly exposing the entity. Now the third problem comes is the lazy loading issue. The lazy loading part we can discuss in later when we know more concepts in backend, but for now you can understand with this, like if the entity has many to one or one to many relations. Say for example user has the list of orders, right? So it comes as one to many. The Spring might try to serialize everything and it causes the performance problems, stack overflow errors, and unexpected big payloads. So these are the lazy loading problems that are caused when you directly expose the entity. So for now we won't talk about it in detail. When we cover more backend concepts, you will get more idea. So let's talk about another issue which we get when we directly expose the entity, which is lack of control over the API. So you lose the ability to customize the API. Say for example, in API, what you want to also send is like you want to compute some of the additional feeds and you want to send those. But if you are just sending the entity, how can you send another computed field? Similarly, if you want to hide some of the sensitive data or field, you can't do that because you have exposed the complete entity now. So basically you can't do any customization. You can't add any new field because it's not a model. You have your entity and you can't also hide some of the information. Everything is exposed to the outside environment which is present in your entity. So these are the problems when you expose the entity directly. So what's the solution then? The solution is DTOs, data transfer objects. So what we want to do is, as a step one, we want to map our entity to DTO. So you can imagine it as an additional class which can have additional fields as well, or it can hide some of the data of the entity as well. So once we are done with the step 1, the step 2 is that DTO acting as a middleman. So it acts as a bridge between the entity and the API. So now for example, this is your entity, okay, and this is your API. So earlier we had the tight coupling between the entity, was your entity, and your API. These were directly connected, right? The entity was exposed to the API directly. Now in the middle you have this your DTO, okay. So the DTO is acting as a bridge. So basically first you map your entity to DTO, and then DTO is exposed to the API. Via this we have the flexibility that we want to add something new, rename the entity things to some other things which are more user friendly, and hide some of the data of the entity, and then DTO is exposed to the API. So this is the step 3, that DTO is sent as a API response. So 3-step process. First you map your entity to DTO, then the DTO acting as a middleman, and then you send your DTO as the API response. Let's understand this with code so that you know the real life example with it. So okay, the step 1 would be to create the DTO, just like we talked here. We have to map the entity to DTO. So the first step would be that you create a DTO. Okay, so for the user entity that we had, we will create a user DTO. Let me show you again our user entity. So this was a user entity. It had the ID, username, password created at and updated at. So now we have the flexibility in the user DTO. It's up to us whatever name we want to give, whatever fields we want to hide, whatever additional fields that we want to add as a new computed or customized field, we can do that. So for example, in this DTO we have kept only 2 fields because in the front end or in the API we only wanted to expose only 2 fields. So one is the ID and other is the username. So you can see we have kept only few of the fields from the actual entity. We don't expose the password here. So it's totally up to us what all fields we want to keep. We can keep additional field as well. We can rename the fields as well. So then we have the constructor, and then we have the getters for the fields that we want to expose to the outside environment. So we are following the basic OOPS concept like we discussed in the last video. So for example, the fields we are keeping those private and we are exposing those using the getters. Okay, once we are done with the step 1, we go to the step 2, which is map entity to DTO. So there are multiple ways to do that. So the first way is doing the manual mapping. So this is fine and simple way when you have small cases, but you know doing manual things can create problem. So for example, it's a very big case, a lot of fields, then there is a chance of error while doing it manually. You also have a support of libraries. Some of the libraries are MapStruct, Model Mapper. So these you can use when you have like big apps. So let me show you one of the manual example, and then later we will also check about the libraries, how can we map the entity to DTO. So first is a manual example. You can see here, this is the mapping that we are doing. We are using this annotation get mapping. So this is a method. You can see we have kept it get user, but it is returning user DTO and not user. So user was the name of our entity class, and user DTO is the class of the DTO that we have now formed. So this method is returning user DTO. So it's not exposing the entity, it is exposing the DTO class. So we are doing the mapping based on the ID. So you can see in the argument as well, we are taking the ID. So what we are doing is like, first of all, fetch the user from the user repository based on the ID, because here we are treating ID as our primary key. So based on the primary key ID, you get your user from the repository, or you can say from the database. We are fetching the user entity based on the ID, and then we map it with the user DTO, and finally we return that. So we are returning the user DTO here. So we are doing the mapping and returning the user DTO. This is the manual mapping example. So now once we are done with that, the step 3 is that we can control our endpoints. We can customize our API. So for example, you have your CRUD operations, create, read, update and delete. So all these operations you can perform using the DTO class. So here for the create, we use a user create request DTO. For update user, you have your user update request DTO, and return user, use a user DTO or user response. So you can see we don't now expose the entity. We can create different DTOs as per our requirement, and we send that in the API. That gives us a lot of customization. Let's see a few of the benefits that we get when we use the DTOs. So here you can see the first one is the security. It prevents exposure of the sensitive fields. Say for example, we had our user entity, right? It had the ID, it had the username, it had the password. So the password was sensitive field. So in the user DTO, we did not expose this password field. So it adds on the security. You are given the customization, you can hide the sensitive fields so that those are not visible to the outside environment. Another benefit is the decoupling. We saw earlier that tight coupling was an issue when you expose the entity. Now the DTO adds a decoupling because it is acting as a middleman between the entity and the API. So on the left side you can see this is an entity, and on the right side it was your API. So what happening is that the DTO is acting as a middle bridge in between these and helps in like decoupling. So now you have the flexibility to change the DB schema. There can be changes in entity, but that will be handled in the internal implementation or the mapping between the entity and the DTO. So it won't break the API anymore. So it adds a lot of decoupling. Third benefit is the customization. Now because you have a separate DTO, you can add some new field to it. Like you are doing some computation, you want to add something new, so you can do that in your DTO. That does not need to be present in the entity. We are adding a new field simply in the DTO. We are calculating some of the things from the entity, the database, and then putting that only for the API. Say for example, just a random thing, you can add some performance related thing here which you can send it to the API. That does not need to be part of the entity or the database. Similarly, as we talked, we can hide some of the fields, we can rename some of the things. So everything you can do that can provide a lot of customization for you. Also another benefit is the maintainability. It also helps you in testing. And another benefit of using DTO is the serialization control. We saw the lazy loading problems, so that is removed using the DTO. So these are the benefits of using the DTO. We earlier discussed about the manual way to make the mapping between the entity and DTO. Now let's see the other way, which is using the library for mapping between the entity and the DTO. So we can use two libraries. One is the map struct, which is the preferred one. It works on the compile time and it is very fast. The other one is model mapper. It works on runtime and overall easier to start. Let's see an example of map struct. You can see we have used the annotation mapper and we have given the component model name as Spring. So there is an interface which we named as user mapper, and in this we return user DTO, and as a parameter it takes user entity, and inside the controller we are using another annotation which is get mapping, and it does that based on the ID. So you can see the same method get user as we created earlier. It returns the user DTO, but instead of like doing it manually, but now we are using the annotations of the library. So here you can see we are getting the user based on the ID from the database or the repository, and then we are simply converting that entity to the DTO. Alright, so now the main point or summary of this video is like, should the entity classes be directly returned from the controllers? Answer is no. You should not return the entity class directly because they expose the sensitive data and they lead to tight coupling. And there are many other issues, like you can't do customizations, you can't hide fields, you can't add new fields. Any changes in the schema of database or in the entity can break the API. So you should never return the entity classes directly from the controller. What you should do is you should use the DTOs. So using DTO is the correct way and returning the entity class is the wrong way. So whenever confused, you have to go to the DTO side. You have to use the DTO and should not return the entity class from the controllers. So this is a very fundamental and important thing that you should remember. This is used in day-to-day work of backend and also asked in the interviews. So you should remember these fundamentals and apply these logics. I hope you got some understanding because we also checked some code in Java, like how things work and what was the issue case and how we solved it. So this was about the DTOs, that is the data transfer objects. I hope you got a good understanding. If you found this video helpful, press the like button and share it with your friends so that all of us can become backend pros. Alright then, this is Mohit Chhabda signing off. Subscribe to the channel and thanks for watching.